Problem 6, find the limit as x approaches 0 of e to the 2x minus 1 over e to the x minus 1. First thing that we always want to try to do is just plug in 0. So if I plug in 0, I'm going to get e to the 0 minus 1 over e to the 0 minus 1. That gives me 1 minus 1 over 1 minus 1, and that equals 0 over 0. That doesn't mean that I don't have a limit. That just means I can't do it that way. So I need to try another approach. One thing that I do notice about the numerator is that this is a difference of squares. It could be rewritten as e to the x plus 1 times e to the x minus 1, because notice if I FOILed that out, I would get e to the 2x minus 1. And then the denominator is still just going to stay e to the x minus 1. And notice now I can cancel the e to the x minus 1s. So my problem is now the limit as x approaches 0 of e to the x plus 1. And my goal in this is to be able to plug in 0, so now I can actually plug in 0 and get an answer. E to the 0 is 1 plus 1 is 2, so my limit would be 2. Problem 7. Assume that f of x is equal to x squared minus 1 times x squared plus 1. Which of the following gives the number of horizontal tangents of f? Couple things here. It's not asking me for what is the horizontal tangent, it's just asking me for how many will there be. So how many answers? Okay, and then horizontal tangents. Tangents is a derivative. If I have a horizontal tangent, the slope would be 0. So it's basically asking me for where would the derivative equal 0? How many places does the derivative of f equal 0? So first thing that I'm going to do is find the derivative. But before I do that, we could use the product rule, or I'm just going to FOIL this out first. If I distributed that, I'm going to get x to the 4th minus plus x squared minus x squared minus 1, and those cancel. So f is really just x to the 4th minus 1. And then if I take the derivative of that, I'll get 4x cubed. And again, if I want a horizontal tangent, I want to know where does that derivative equal 0. So I'm going to set that equal to 0. I'll get x cubed equals 0, and the only place that that happens is at x equals 0. Notice that 0 is one of my answers, but that's not what I was looking for. I want to know how many horizontal tangents did I have. The only one occurred when x equals 0, so there was only one horizontal tangent. So B would be my right answer on that one. Okay, number 8. On the interval from 1 to 2, the curve y equals x cubed minus 6x squared plus 9x plus 1 is what? So it's talking about increasing and decreasing, and it's talking about concave up and concave down. So first thing that I'm going to tackle is the increasing and decreasing. So I'm going to find the first derivative, which would be 3x squared minus 12x plus 9. And I would like to find some critical numbers so I can make a y prime chart. So I'm going to set that equal to 0. And next thing that I'm going to do before I try to factor that, I'm going to factor out a 3. And then I do notice that factors into x minus 3, x minus 1. So my critical numbers would be at 3 and at 1. So if I do a y prime chart, 1 and 3. Let's see, if I put 0 into the derivative, I will get a positive. If I plug 2 in, I'll get negative. If I plug 4 in, I'll get positive. So if I look up here on the interval from 1 to 2, so 1 to 2 is somewhere in this area. And so I notice that my derivative is negative, so I know that my function has to be decreasing. Okay, and then if I'm looking for concave down, so gone, y double prime would be 6x minus 12. Again, I would like to set that equal to 0. If I factor out a 6, my critical value would be at 2. So I'm going to make a y double prime chart. I'll plug 2 on it. If I plugged 1 into the derivative, I'm going to get a negative answer. If I plug 3 in, I'll get a positive answer. And this interval is from 1 to 2. So the interval from 1 to 2 would be over on this side of my chart. And I notice that my second derivative is negative, which means my graph is going to be concave down. So the choice that I'm going to pick is decreasing and concave down. Okay, question 9. Evaluate the integral from -4 to 4 of 4 minus the absolute value of x. Okay, there are several different ways to do this problem, but I'm going to try to take the easy way out here. There's a minus sign right here, which means I can separate this into two different problems. So we're going to go from -4 to 4 of 4 minus the integral from -4 to 4 of the absolute value of x. All right, this first one, we can just go ahead and take the integral of 4, which is 4x. I'll evaluate it at 4 and -4. So if I plug 4 in, I'll get 16, minus if I plug negative 4 in, I'll get negative 16, and those combine to give me 32. Okay, the second part, there's an easy way and a long way. I'm going to do the easy way, and I might do the long way, we'll see. The absolute value of x, I know what the absolute value of x looks like. It looks like this right here. And I want to find the integral from negative 4 to 4. And as long as I have a picture, it's just going to be the area underneath the curve from negative 4 to 4. And I notice that they're just two triangles. So we'll call this triangle A and this triangle B. The area of the first one is going to be 1/2. The base of that one is 4. And the height of that one is also 4. So the area would be 8. And then B, pretty much it's the same triangle, but we'll just do it for funsies here. 1/2 times 4 times 4. That also gives me an area of 8. So if I put those together, it's 16. So I'm going to have minus, this answer was 16. So 32 minus 16 is 16. So my answer would be choice D. Another way that I could have approached this one, I'll just kind of get it started for you, but I don't think I'll do it the whole way. We could have, with absolute values, figured out where would this absolute value be 0, and that would be at x equals 0. So we could have split it into two graphs. We could have gone from negative 4 to 0 of x, and remember we have to take the opposite of that first one, and then plus the integral from 0 to 4 of x. And then I could have actually evaluated those. This would be negative 1/2 x squared, evaluated from negative 4 to 0, plus this would be 1/2 x squared, evaluated from 0 to 4, and then blah, blah, blah. We could finish it up, and we would end up with the exact same answer. So either way is 100% correct. I just figured the picture way this time was a little bit faster. Okay, problem 10. If the integral from 2 to 5 of f of x is equal to 18, then the integral from 2 to 5 of f of x plus 4 is equal to what? Okay, same thing as we did in problem 9. There's a plus sign, so I'm going to go ahead and separate it into two integrals. So it's going to be the integral from 2 to 5 of f of x plus the integral from 2 to 5 of 4. Okay, this first one, they told me the answer for the integral from 2 to 5 is 18, so that one is just all set. On the second one, we can actually just calculate the integral of 4 is 4x. I get to evaluate it at 5 and 2. So if I plug in 5, I'll get 20. And then minus, if I plug in 2, I'll get 8. 20 minus 8 is 12. So this will be 18 plus 12, which gives me 30. So 30 would be my correct answer.